Okay, so we're finishing up test 10, section 5. And in this video, we're going to do numbers 17 to 20. And this starts off on page 969. So let's get right into it. 17. We're in the difficulties now, so keep that in mind. If k and h are constants, and x squared plus kx plus 7 is equivalent to or equal to x plus 1 times x plus h, what is the value of k? And they give us a bunch of choices. First thing first, e, it cannot be determined from the information given. That is almost always wrong, so cross it out immediately. So we're down to 4. All right, so they want to know what is the value of k. Well, let's do some rearranging here. Let's FOIL this out. X squared plus kx plus 7 equals, well, so we do this times this, x squared plus hx plus x plus h. Okay, well, let's go ahead now and look at these two compared equations. This x squared matches up with this x squared, no problem. This kx term is going to match up with whatever this hx plus x term adds up to. And then most importantly, this 7 is going to match up with this h. So what does that tell us about h? Right, it tells us that h is going to have to equal 7. Otherwise, these two equations are not going to be equivalent. So knowing that, let's go ahead and plug in h is 7. X squared plus kx plus 7 equals x squared plus, well, we know h is 7, so 7x plus x plus 7. Let's do it one more time. We know this is going to equal x squared plus 8x plus 7. So reasoning the same way, we know that this k term is going to have to equal this term next to this coefficient next to the x. So what does k equal? K equals 8. That is choice D. Now we're moving on to number 18. Another figure not drawn to scale problem, so keep that in mind. In the figure above, if the legs of triangle ABC are parallel to the axes, which of the following could be the lengths of the sides of triangle ABC? Alright, so they don't give us much information, but they actually do give us enough to do this. So here is our picture. Goes something like this. A, B, not very straight, but oh well. C. And they tell us this point here is point 410. Kind of random, but it'll be important in a second. And we want to know what is the shape of, what is the length of the sides of this triangle. The reason why they tell us figure not drawn to scale, that means we can't simply guess what this could be by drawing it out by measuring, because the figure is not drawn to scale. We have to use the picture. Well, what are we going to do? Well, they give us this point 410 for a reason. We have a point here, and we know it goes through the origin, 0, 0. So what then can we figure out about this line? Well, we can figure out the slope. y2 minus y1 over x2 minus x1. So in this example, it's going to be 10 minus 0 over 4 minus 0. So the slope is going to be 10 over 4. Now, what does that tell us? Well, or, aka 5 over 2. That means for every rise of 5, we move over 2. Rise of 5, we move over 2. Rise of 5, we move over 2, right? What have I formed here? I formed triangles. Well, what does that then tell us about the sides? Well, that would tell us that for this rise of 5, we could go what is it? Rise over run. We've run 2, right? Here's our slope. We've gone up 5 and over 2. Another way to do it. So this is a way of approximating the sides of the triangle. Now, it also could be any ratio of this. It could be 4 and 10. It could be 6 and 15. It could be some fractional ratio of that. It doesn't matter. As long as it's in the ratio of 5 to 2 or 2 to 5, right? Remember, this is rise over run. Hope you can see that. So that we know this is going to have to be 2, this is going to be 5 by the fact that the slope tells us that that is how fast the line goes up. So this is actually a slope definition problem. So how do we get this third side? Well, we could also eliminate C, because that's 3 and 3. D is 3 and 4, and E, which is 4 and 5. So none of those are good. We can get rid of B2 even, because we know this is not going to be 7. That's too easy. Let's do the Pythagorean theorem to figure out what this third side is going to be. So it'll be 2 squared plus 5 squared equals C squared. 4 plus 5, or 25, equals C squared. So this is going to be 29 equals C squared. C equals rat 29. And what do you know? Choice A is our choices, right? 2, 5, and rat 29 as our 3 sides. So the answer here is going to be A. 19. Let the function f be defined by f of x equals 2x minus 1. if 1/2 f of rat t is 4, what is t? Well, let's just go ahead and plug in for the functions. We know f of x is 2x minus 1. We want to know f of rat t. That's just going to be, we'll plug in rat t wherever you see an x. That'll be 2 times rat t minus 1. Then we know that 1/2 of this, so 1/2 of f rat t, is just going to be 1/2 of this whole guy. That equals 4. Alright, well let's multiply both sides by 2 to get rid of the half. We get 2 rat t minus 1 equals 8. 2 rat t equals 9, just adding 1 to both sides. Rat t equals 9 over 2. Square both sides. We get t equals 81 over 4. And that is choice E. Last one, number 20. If k is a positive integer, or I should just say k is greater than 0, which of the following must represent an even integer that is twice the value of an odd integer? Very weird. We get 5 choices. 2k, 2k plus 3, 2k plus 4, 4k plus 1, 4k plus 2. So let's start out with k is, 3. Plug in our own numbers here, right? That's the best way to test this. And see which one of these works given that. The only thing we know is k is a positive integer greater than 0, so it's got to be 1, 2, 3, 4, 5, 6, 7, and so on. So let's start with k is 3. So 2 times k, that'll be, 2 times 3 is 6. Now, is that an even integer? Yes. So that's good. Is it an even integer that is twice the value of an odd integer? Well, yeah, it's twice the value of 3, which is an odd integer, so this works. How about here? 2 times 3 plus 3. That's 6 plus 3, which is 9. That's an odd integer. We're automatically disqualified. 2 times 3 plus 4 is going to be 6 plus 4, which is 10. So that's even. Is that 2 times an odd? Yeah, it's 2 times 5. So this one works. 4 times 3 plus 1 is going to be 12 plus 1, which is 13. That's odd, so we can immediately get rid of this. 4 times 3 plus 2 is going to be 12 plus 2, which is 14. That's even, and it's 2 times 7, so that works. Alright, so we're stuck between these 3. Now, if we plugged in k is 5, k is 7, k is 9, we're going to get the same answers here, because these work with odd integers, these 3. Let's start off then with k is 2. That's an even integer. That should change the pattern. So let's try this. 2 times 2 is going to be 4. That's an even integer, but listen, it's 2 times 2. It's not 2 times an odd integer, so we can get rid of A. How about C? 2 times 2 plus 4 is going to be 4 plus 4, which is 8. So it's even, but it's 2 times 4. It's not 2 times an odd integer, so no good. So E better work. 4 times 2 plus 2 is 8 plus 2, which is 10. 10 is even integer, and it's 2 times 5, which is an odd integer. So the answer here is E. So that one's hard because you got to keep track of all the definitions and everything going on with that problem. But if you can be systematic about it, if you can do it step by step, you should have no problem getting the answer. So that's it for section 5.